Welcome to week 12 of our Calculus 2 course. Today we'll talk about how to calculate distance between 2 points on the curves. Imagine that we have 2 points that have coordinates x1, y1 for the point that lays on red and x2, y2 for the point that lays on the blue curve. If we want to calculate length of a hypotenuse in the right triangle, we'll just use Pythagorean theorem. Therefore, the distance between the 2 points is going to be equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. However, if we have a simpler case where the x-coordinate of the 2 points are identical, then the distance is calculated using much easier formula. The distance between the red point and the blue point is going to be just the difference of y values. If we don't want to deal with the absolute values, we can calculate distance between the 2 points by taking difference between the y-coordinate that is larger, I'm calling it y top, and the y-coordinate that is smaller, y bottom. Or in this particular case, the distance between the 2 points is exactly equal to f of x minus g of x for a specific value of x. Let's look at the following example. If the top function y equals to x squared plus 1, this is our function f of x, and the bottom function is the horizontal line y equals minus 2, this is our function g of x, then the distance between point that lies on a parabola and the point with the same coordinate x that lays on the line is just the difference between f of x and g of x. The top function f of x is x squared plus 1, the bottom function is minus 2, so f of x minus g of x would look like x squared plus 1 minus minus 2, making it plus 2. So x squared plus 3 is the distance between any 2 points on a parabolan line that have same x-coordinate. Now let's take a look at the case where the 2 points belonging to the functions f of x and g of x share the same y-coordinate but do have different x-coordinates. The distance between those 2 points will be simply the difference between the larger value of x and the smaller value of x. In order to find the larger and smaller value of x, we would have to find inverse of the function f of x and g of x. Then the distance between those 2 points would be the distance between the rightmost value of x and the leftmost value of x, which is the same as the inverse of the function f of x evaluated at that specific value of y minus inverse of g function evaluated at the same value y. Let's take a look at the example. Let's find a formula that expresses the distance between any 2 points that share same y-coordinate, where one belongs to the curve y equals square root of x and other belongs to the curve y equals minus x. As we know, the distance between those 2 points would be the rightmost x value of the point minus the leftmost x value of the point. Let's take a look at the equation y equals minus x and solve for x. Clearly, x is equal to minus y. So whatever value of y is equal to, the smallest value of x would be equal to negative y. If we look at the rightmost point, its x-coordinate comes from the equation y equals to square root of x. To find the rightmost value of x, all we need to do is just square y. Therefore, the distance between the 2 points on the curve that share the same y-coordinate is calculated by a formula y squared minus y, or y squared plus y. The last case I want to consider is when 2 functions f of x and g of x switch positions. So for some values of x, function f of x is on top, and in the other cases, function g of x is the one that is larger than f of x. Let's express the distance between the 2 points with the same x-coordinate, that one belongs to the curve y equals x cubed, while other belongs to the line y equals 1. The difference between y values, if x is less or equal 1, would be y equals to 1 minus y equals x cubed. So it's 1 minus x cubed. However, for the x value strictly greater than 1, the difference between the y values is equal to x cubed minus 1. So here, formula very much depends on which value of x we are considering at a specific time. I hope that this review is useful to you, particularly when you're setting up formulas for the volume calculation of the 3D solids. Until next time.